This is Philip. This is Cecilia. Philip says, "You up?" Cecilia answers, "Yeah." Philip says, "What you doing?" Cecilia says, "Not much. Just found my favorite number. Integer, by the way." Philip says, "What is it?" Cecilia doesn't answer. Philip gets interested. She's playing hard to get. Is it divisible by 1? She still doesn't answer. Is it divisible by 2? She still doesn't answer. He asks, is it divisible by 3, 4, 5, 6, 7, 8, 9, or 10 even? And then she answers. She says that the question to all of those is yes, except one, where it doesn't even have any common factor, except one. So this was actually a question on a math competition I attended. So formally, the question is phrased as Cecilia answers yes to all questions except one, where she answers no. There isn't even any common factor except one. And the question is, which number, which question did she say no to? So let's start from the beginning. Is it divisible by 1? Well, since Cecilia's favorite number is an integer, it is obviously divisible by 1. Philip is obviously retarded. Um, then he asked, is it divisible by 2? Now we actually have to think. So, if it wouldn't have been divisible by 2, could it have been divisible? That means she answered no to that one and said yes to every other question. Meaning she said that it's divisible by 4, but not 2, which doesn't make any fucking sense, since 4 is a multiple of 2. So therefore, she couldn't have said no to 2 either. The same logic applies to 3. If you would have said no, it isn't divisible by 3, but then said yes to 6 and 9, that also would have been incorrect. So therefore, assuming that Cecilia knows her math, which she does, 3 can't be the answer either. The same logic applies for 4. Since 8 is a multiple of 4, if it wasn't divisible by 4, it couldn't have been divisible by 8. So therefore, we also cancel that out. Same thing with 5 and 10. If she said no to 5, then she also would have had to say no to 10. But she couldn't have, since she only answered no to one question, so that doesn't work either. Now we can't make our way up anymore, so we have to think backwards. If she said yes, sorry, if she said no to is it divisible by 6, then that would mean that she said that it is divisible by both 2 and 3. Is that possible? Well, no, since 2 times 3 is 6. If it's both, if it's divisible by both, then it's obviously divisible by 6. So, well, we will cancel that out. You can also, if you think of it this way, you have Cecilia's favorite number C. If it's divisible by both 2 and 3, you can say that it is some factor of 2, 2 times some integer k, times some, and it's also divisible by 3, so it's also times 3, and then some random integer n, which is obviously just 6 times kn. So it's also divisible by 6. That's just a quick representation. 7, we can't really utilize the tactics we've used this far, since 7 is a prime number and isn't a multiple of anything in the range. Or anything in the range is a multiple of 7. So we'll just leave that be. So with 8, we have to use the extra comment that she said. Because since the tactic we used with 6 was that 2 times 3 is 6. And of course we know that 2 times 4 is 8. But something divisible by 4, by only 4, like the number 4, is both divisible by 4 and 2, but it's not divisible by 8. So here's what we have to think about. She said that no. Her answer to the question which she said no to was no. There isn't even any common factor except the 1. So if it was divisible by 2 and 4, but not divisible by 8, she would have said that there was some sort of common factor, because 8 is a multiple of 4. Okay, think of it this way. If we have that C is equal to, use new constants here, 4m, and you ask, is this divisible by 8? There's obviously a common factor. It says C is equal to, you can interpret it in this way. If you say that C is equal to 4m, where m is some random integer, then when asked, is it divisible by 8? She would have said that, well, 4 is obviously a common factor in 4m and 8, which is equal to 4 times 2. And since she said that the only common factor, the greatest common factor even, was 1, then this can't be the case, and therefore 8 can't be the answer. The same logic applies to 9. If it was divisible by 3, but not 9, she would have answered no, there is a common factor, because if it's a multiple by 3, then a common factor of 3, a multiple of 3 and 9 is obviously 3, because 9 is 3 times 3. So 9 can't either be the case. And the same thing applies. And actually for 10 we can just use the fact that 10 is equal to 5 times 2. And since 5 and 2 are both prime numbers and don't have any common factors, it's the same as 6 with 2 and 3 respectively. So it can't be 10 either. So we have it. We have the answer. It is 7. So Cecilia answered yes to all of these questions except this one. It is not divisible by 7. It doesn't even have any common factor, which makes sense because 7 is a prime number. So yeah, what we can do now, if we would like to, is to figure out the least possible favorite number for Cecilia. But you'll have to do that for yourself and leave it in the comments. And so yeah, that was the first problem on the math competition I was in. Quite easy. Yes. Have a good one. Bye bye.